Hey, I'm Matt Compton. I am from Atlanta, and I work for a small startup named Luma. And today, I want to talk to you all about Lint. Now, you're all Android developers, and you've probably been using Lint this whole time. Maybe you've realized it, maybe you haven't. It's really well integrated into the IDE. But my goal is to show you how to really utilize Lint to the fullest extent of its abilities so that you can make your own custom Lint checks for whatever purposes you might need. Oop. Oh no, the old clicker. Well, we'll use the laptop instead. So like I said, I work for Luma. It's a small startup out of Atlanta. We build routers. So your stereotypical router is this big clunky machine that's kind of annoying to configure. We instead give you 3 smaller routers about the size of your fist that you spread around your home to improve connectivity. They work together through mesh networking, and then you can control the router through your smartphone. So that's what I do. I build the Android app for a router company. I'd also like to give a shout out to Big Nerd Ranch. I wrote this talk while working for them. They're a wonderful company. They have great classes, books, and training, so check them out if you haven't. So the big question is, what is Lint? It's a static analysis tool built in the 1970s out of Bell Labs, and it's been ported to every major programming language. I like to think of Lint as my detail checker. It helps me keep track of small, fine-grained minutiae in my code base that otherwise might have been lost. In Android, we have all these large pieces that we have to keep track of. You have your view layer, your model layer, you have to deal with fragments and activities, or Arcs, Java. So sometimes you can get lost when it comes to small details. That's what Lint excels at. It helps you keep track of those little things. Now, a great example, and leading from Kelly's talk, is content descriptions. So content descriptions, you're probably familiar with this Lint check. It's saying, hey, you have an image view, or you have an image button, and you didn't give any sort of accessibility description along with it. And as Kelly showed us, accessibility is important. This is one of those details that a lot of developers might otherwise miss or gloss over, or maybe they relegated it to the back of their backlog. Now, as you can see, Lint has a fairly tight integration to Android Studio. It'll pop up, it'll yell at you and be like, hey, you forgot this, take a look, maybe you should fix it. And sometimes you can even option enter, or whatever the equivalent is for Windows, and it'll fix it for you automatically. Not in this case, but sometimes you have that nice integration where Lint will fix things for you. So Lint can be useful for helping keep track of these details. Now, my goal in this talk is to show you how to make your own Lint checks. I built several for my projects, and I found that there's really 2 big use cases for writing your own Lint checks. The first is if you are a library or SDK developer, then bundling a Lint check with your library or SDK can be really helpful when a developer is trying to use it. You can give them some guidance on how to use your library. A great example is Butterknife by Jake. It includes several Lint checks to make sure that, hey, are you using this library correctly? And that can be really helpful, especially if someone hasn't used an annotation processor before. So that's use case 1, libraries and SDKs. Use case 2 I found is domain logic or business logic or something specific to your company or the project that you're working on. A great example is Captain Train. Jeremy Martinez from Captain Train always prefixes their custom XML attributes with CT for Captain Train. This way they always avoid any naming conflicts or resolution problems when they're using libraries. That's just one example. Anything that's related to your core business logic or maybe your project, anything that's repetitive or like a detail-oriented, you could write a Lint check around that to automatically make sure that your team follows those guidelines. Now, I wouldn't necessarily use it for code styling, because there are other tools that do that better, but little details such as prefixes or maybe how to use your library or SDK correctly. Now, the example we're going to follow through this talk focuses around enums. I came up with this idea last year after DroidCon New York when the big buzz in the community was all about whether to use enums or not. Personally, I think enums matter, but that's a religious war for another time. What I'm going to show you how to create is a lint check to detect and scour your code base for all enums, then yell at you when you use them. So here's what it looks like. You've ran lint in Android Studio, and it spits out all these different problems you have. You can see I have some obsolete Gradle dependencies. Maybe I don't have my padding and margin symmetric. And then that last one, it'll show up whenever you're using a custom lint check. It'll say, hey, you got this special warning from some lint check that isn't part of the core library. Mine, for example, just says, hey, you should avoid using enums. I don't know what pet.java is, but I know it's an enum, and I don't like them. And so that's what we're going to be seeing. Now, the core library has around 200 different issues that it can scour for, and it'll look and alert you whenever they're used. So these are the core parts of a lint check. There's an issue, detector, implementation, and registry. And I'm going to give you a high-level description of them now, and we're going to dive into each of them and how to create them throughout this talk. The issue is what we're looking for. It's the problem to be solved. It's, hey, you forgot the content description. Or, hey, you have nested linear layouts with weights. It's what we're trying to solve. The detector is how you're solving it. It's the big piece of your lint check, and it's really where most of your core logic and programming will go into. The detector is your controller, and it's kind of your equivalent of an activity or fragment. It's what's doing the heavy lifting, that detector. So we have our what, we have our how. Implementations are the where. It's where we're looking. And this can range from Java files to XML files, really anything that can be included in your project. So you can hook into Gradle files, and then just generally anything, including class files if you want to look at compiled code. So that's much harder. And the final piece is the registry. And this one's simple. It's just a listing of all of your special lint checks. The default lint API has a custom built-in registry, which just lists all the different lint checks part of Android. We're going to have to provide our own registry since we want to provide our own custom lint checks. Ours will be simple. Since we're making this enum example, we'll only have a registry filled with a single issue. So that's our high-level description. Issues are what we're looking for, detectors are how we find them, implementations are where we're looking, and registries is just a nice category listing of what we care about. And I'm not a graphic designer, so I know my diagram's not the best, but this is a nice high-level overview of the architecture of how these pieces can fit together. An important point that I want to make on this slide is that these pieces can be reusable and modularized. So I can have multiple issues found by a single detector is the idea. My registry is listing all of my issues. Multiple issues can reuse the same implementation, which is where we're looking. And you can mix and match these as needed. So if you create an implementation that is looking for Java files, then you can reuse that across multiple issues that also happen to be found in Java files. Now, probably the most important piece is that detectors can look for multiple issues. This is great because we wouldn't want, say, 100 detectors to all be searching through the same files over and over and over, because that would be a bit redundant. Instead, we can have a single detector go through, say, the Android manifest and find multiple issues. There's a lot that can go wrong in your Android manifest. You could have a version mismatch. You could be missing an attribute. Maybe your build tools are out of date. So we can have a single detector find multiple of those problems in a single pass. This way, it saves us a little bit of time. Now, once we've actually built up our lint check and generated it, it ends up being a jar. And this jar will contain your registry. It'll contain your detector logic of how to find this issue. And wherever you put this jar is hopefully will be included into your path. So I just stick mine in the .android in my home directory. in the lint folder. It should be provided for you by default, and it'll probably be empty unless you've done any lint work before. So at the end of all this, we're provided with this nice jar, and you can stick it here locally in your machine, or you could throw it into continuous integration and have it be used by your entire team. And that's kind of the benefit of a jar. You can just have that output be used wherever you actually need it. So we're going to go through the steps. We'll start with updating our dependencies, which is where a lot of great journeys in Android development begin. The next step will be our implementation, because we've got to figure out where we're looking really before we determine what we're looking for. Then we'll create our issue, our detector, registry, and finally, and I want to stress this, we want to test. Lint checks, unlike many parts of Android development, are actually really easy to test. We simply can provide a file that contains the error and a file that does not contain the error. And that's pretty much it. We'll run lint on those files locally, and then we can check the output. So I highly recommend testing, and I'm not a test-driven development advocate by any stretch, but this is actually a pretty great use case for it. So we'll start by upgrading our dependencies, and we're just going to use the COM Android tools, Lint, and the Lint API. This is not up to date. I'm using an older version of the API, 24.3.1. There are newer versions out there, but Lint is constantly changing. It's a non-final API, it's going through revisions, and it's never really gotten to a point where it's finalized. So you can't count on the Lint API remaining static and remaining reliable. It's going to change and it's going to break. And that's okay. The core ideas of this talk will remain constant. The ideas of issues and detectors are still there, even though maybe the names or method calls or the slight details of the API might change. The central themes will remain constant throughout the API levels. But our code examples will be using this version. So we're going to start with our implementation. This is where we're looking, and we have a couple different options that we can use. Basically, we have to define the class of our detector, which is something we'll define later on in the slides, and then the scope that we care about. So this implementation is not only where we're looking for our issue, it's also kind of a bridge between our detector and our issue. It connects them. So in this manner, our detector, which will be doing the heavy lifting, will be connected to a particular issue and know where to look for it. Now, here, since we're looking for enums, and we know that enums will appear in Java classes, we're going to define our scope as, hey, scope.java file scope. If we were looking for something in the Android manifest, it would be an XML file scope. If we were looking in Gradle, it would be Gradle, and so on and so forth. And that's about it for the implementation. It's really just this bridge between our detector and our issue, and it's holding on to where we should look for our different issues. Issue is the important piece. It's the problem that we're trying to solve. And it has a bunch of different fields that we can define. Now, the first one's the ID. This is how we uniquely identify our issue. And usually it's some sort of camel-cased phrase. Mine's just enum, but typically you give it a more descriptive ID. Later on, you can do a lint -- show with an ID, and you can learn all about the details via command line. The description is that pop-up text. It's that short, hey, this is what's going on. It's, you should add a content description to your image view. You should avoid using enums. It's a short, brief message to your developers to let them know what's going on. Now, the explanation, however, is your longer, should be theoretically multi-paragraph explanation of why this is an issue. So with content descriptions, you give an explanation of like, hey, accessibility matters. You should actually add these, and it's not that hard. Here, for brevity's sake and for slides, I just say never use enums. But that should be a longer description to give the developer, which is your user in this case, some context of why this is an issue. Your category, of which there are many predefined categories, is an idea of what type of issue this is. Mine, I say performance, because of the idea that enums maybe take up too much space or whatever. But you have other categories as well. Correctness, you can go with accessibility, and then if you can't find an existing category, you can just do other. Priority is exactly what it sounds like. It's how important this issue is on a scale of 1 to 10. I say 5 because, hey, this is kind of middle of the row. It's not a big deal. 1 means, yep, doesn't matter. No one really cares. It's just kind of here for the sake of it. And then 10 is your code's on fire, run for your life. And severity is perhaps the piece of lint that you might have touched the most. The severity is how it interacts with your build process and your build tools. Here we say warning, as it'll not fail your build, but it will let you know, like, hey, this is a problem. It's probably something you should fix. But go ahead and continue building and running your application. We'll delve into the severities in more depth in a moment. And to create an issue, we just have this nice constructor, or this creation method, I should say, where we do issue.create, and we pass in all of those fields we defined on the previous slide, plus 1 extra. As you can see, that implementation we defined a few slides ago is also included. Like I mentioned, the implementation is that link between our issue and our detector. So when we define our detector, it'll have access to these issues. And that's kind of how we connect all the things. So, issue severities explained. There's 5 of them. Ignore, informational, warning, error, fatal. Ignore means, I don't care about this. Like, I admit that it is an issue, but it's not important. This is probably what you've done to any lint warning that annoyed you. Hopefully you haven't done this to content descriptions, because those are important, but I know that's a common one you'll see in XML, and maybe you got annoyed by it, and so you put it down and changed its severity from its normal warning and downgraded it to ignore. I don't recommend that. But every once in a while with lint, you have a check that maybe is pervasive in your code, and you need a way to change its severity. Callie actually talked about the opposite, which is taking one that is warning for content descriptions and boosting it up and saying, hey, this should be an error. I don't want my build to pass if I have some sort of accessibility problem that's inherent in my app. So ignore means, don't even tell me about this. Informational just means, like, it's a problem, but we still don't really care. But I want it to show up just so I know for my own sake as a developer. I don't want it to affect my build process at all. And I want to know about it. So it's a step above ignore, which will just silently go away and you'll never see again, and gives you some information and context as to what's going on with that issue. Warning means, hey, this is a problem. Take a look. Red text, red flag. I won't fail your build, but you should fix this. It's Lint shaking its hand at you angrily. Error will fail your build. It'll say, hey, you can go no further. Stop here and fix this problem. And fatal means you actually can't package your application. So it'll fail at the APK step. It won't let you build your final product. With error, it'll actually still let you package your APK. It'll fail the build, but you could still package it if you so chose. Fatal will prevent that. Fatal is as severe as it gets, because there's really no farther blocker than not letting you package your application. Now, you can manipulate these severities, and that's kind of an important part of Lint. Things ebb and flow in importance, and maybe at the beginning of a project, you don't necessarily care about accessibility yet. But at the end of the project, it's super critical, and you need to, and so you want to boost it, depending on the point of your project and what your timeline is, and what your business priorities are. And there are a couple of different ways you can change severities of lint checks. So this first one is kind of the inline method. It's the idea that in our Java file, we can suppress lint through annotations, and in XML, we can use the tools namespace to ignore lint checks if we need to. You can see there's a few different ways. So we can either list a single lint ID, which is what we do with inflate params, or we can even list multiple with inflate params and new API. These are all the issue IDs for that lint check, which is why that ID is important. It's how we identify it. Now the second way is in our build.gradle. We can just say with a lint options tag, hey, I want to disable these lint checks. I no longer want them to run in my project. So I no longer want to be notified about new API warnings or worrying about right to left encoding. And finally, you can also create your own special lint.xml file in your top-level project directory. So app/lint.xml, and you can list any issue IDs and give them your own custom severity. So here, if I have a redundant cast, I will say, hey, that's fatal. I never want that in my project and under any circumstances. And so this is probably my favorite approach because it's a nice listing of everything that I'm affecting in one place. So I can list all the issues that I care about and their appropriate severities that I want to shift, as opposed to the previous methods, which were either inline or part of Gradle, which Gradle really just allowed us to ignore the problem. This allows us to really change the severity at a whim. So that's the issue. It was what we were trying to find. Now we're going to move on to the detector, which is how we're going to find it. This is the heavy lifting of the lint check, and it's going to be scouring through our code. In our example, we're going to be talking about Java code. So we're going to be using a Java-based detector mechanism. But this will vary pretty greatly depending on what type of file that you're trying to scour through. And we'll see that in a moment. So here's what our detector looks like at a simple level. I'm going to call it enum detector because it's looking for enums. It extends the detector class as part of the lint API. But most importantly, it implements a scanner. Now, the scanners are interfaces that give you hooks into different slices of code. With Java, we're going to use the Java scanner, and it's going to be using the Lombok API for creating a tree of our Java code and then going through it step by step. So this scanner class will allow us to hook into different pieces of our code. If we want to find a lint check that maybe at the start of a comment or at a field declaration or the beginning of a method call, all of these can be represented through Lombok. So all of them can be hooked into our scanner interface. Now we're in Java land right now, and that was kind of Java specific. But the same is true with XML. We can use an XML DOM parser to turn our XML into something that can be represented, every piece of it, every open brace, every end tag, everything can be represented by the scanner and hooked into. And the same is true for Gradle, same is true for class files. The idea is that no matter what type of file you're looking through, Lint will have an appropriate way of converting it into an easy to hook into scanner interface. So the first thing we do is create our public constructor, just an empty constructor, and the Lint API will be using that to spin up our detector for us. And this is kind of what our code will end up parsing into. So if you're not familiar with abstract syntax trees, it's just a way of representing our code in a different form. Here we're defining some variables x and y, and then we create a while loop that goes for a certain condition, and then we write out some variables. It's not so much important the details here, but it's this idea of we're looking at our code in a different way. Instead of a very imperative line-by-line approach, we've converted it into a tree so that we can hook into these slices of I need to check for my special lint check where an enum is declared and find that exact piece, that exact node in the tree, and then warn using our lint check. And again, if we were using XML or Gradle or class files or whatever, it wouldn't necessarily be represented in the same way. It would have its own utilities, its own parsing mechanisms. But the idea is the same. We have a way of hooking into every bit and piece of our code base. So the first method, and the first idea that we'll look at with our detector is this applies to method. Its idea is trying to figure out if a file that's been provided to us actually matters for this detector. Here I just return true. The idea being I've defined my Java file scope with my implementation, so every Java file will be passed into this applies to method. You can see we have two parameters. We have context, and file. And just to be very clear, because it's ambiguous, that is not an Android context. That is a Lombok context, which is slightly different. So it's more a representation of our tree and has nothing to do with Android. Based on our context and on our file that we're given, we could determine in this method either true or false if this file matters for what we're looking for. In our case, we're looking for all enums. So we're scouring through, and we want any Java files because we got to check if there's an enum inside of it. But if we knew more information, we could be more specific here. Maybe our lint check was really based around naming schemes. And we could actually just take the file handle and look at the name. And we could determine based on that whether it actually should be checked or not by our detector. So we could do a file.getName and then check if it ends with enum, for example, or begins with it, depending on what your naming scheme is. So this is how we figure out whether a file matters to us. It's a way of narrowing down our scope even further. With the implementation, we narrowed it to Java files. Here, we could narrow it even further to more specific Java files. And the same would be true if it was XML or Gradle or whatever. Now, this piece is called getApplicableNodeTypes. Now, if we remember, our abstract syntax tree has parsed our Java code and turned it into this nice tree with all these different nodes. This is where we say what types of nodes we want to look for. And any piece of our code can be represented here. If we wanted to look at a comment declaration or the beginning of a field, we can find those. And those nodes will be represented. And now our detector will make sure to visit inside of our Java file scope, inside of the files we've selected, and now even further narrowed down to these particular nodes. It'll go in and visit at that point. So here, for our sake and for our example, we just care about enums being declared. And so we're going to go into that enum declaration node type, and anywhere in our code base that's Java files and has an enum declaration, we're going to end up visiting that piece and, as we'll see in a few slides, triggering lint and saying, hey, this is a problem. So all of these are about filtering down our scope further and further and further until we have narrowed it down and found our issue, whatever it may be. Now, this next two slides is a bit interesting. So we create jalvavisitor, and what this means is we've narrowed it down to Java files, we've figured out the files we care about, we've even narrowed down to the particular nodes that we care about, for us being the enum being declared. So this is where we actually visit that node. So the visitor meaning we're going to go into that node and do some bit of work. And the Java context is, again, a Lombok context, so it's a place in our Java tree. Now, this enumChecker is a custom class I define on the next slide. And this jalvavisitor will take care of any work that we want to do while we're in that node. So for that brief period of time where we've hit that node, we can check for whatever it is we're looking for. For us, it's easy. We're just looking for enums being declared, so it's kind of tautological. We've found the enum declaration, so we can easily know. But with a more complex lint check, such as nested layouts, your detector could be doing a lot of work. It might need to visit multiple nodes. It could even need to visit multiple files, and maybe even keep track of internal state. This is why earlier I said your detector is your controller class, because it can keep a lot of internal state across even multiple passes through your entire application. Your detector can be arbitrarily complex, though lint will eventually cut you off and say, hey, 10 passes through the code base is too far. We'll limit you there to prevent infinite recursion. So here we have our enumChecker inner class that we've made. The idea being it's our visitor to our node, and we're going to be doing some bit of work here. Really, all it needs to do is hold on to our Java context, so to hold on to where we are in our code base, where we are in our Lombok tree. And here's really, when it gets down to it, the most important method of them all. It's how we visit. It's where we are. It's this visit enum declaration. So since earlier we defined the node that we care about as an enum being declared, this is the only method that will override in this class. But our forwarding AST visitor has all sorts of methods that we could override depending on what we care about. For us, it's enum declaration, but again, you can look for really any concept that can be represented in Java code would have a corresponding method here that we could override. So with us, we have this visit enum declaration, and all we're going to do is say, based on this context that we saved on the previous slide, that Java context that we held on to, so based on where we are, I'm going to use the report method. And that report method is you saying to lint, hey, I found it. I found the issue. Here it is. And we're going to pass in the issue that we found, whatever it may be, a location for that issue, which can be specific. Here, I'm passing in just the file as a whole. So it's like I found it in this file, which is probably enough for looking for enums. But you could be more specific with that location by giving line numbers or even multiple line numbers if you so chose. And we also give a brief description, which I just copy over from my issue description that we defined previously. So we give the issue, we give where we found it, and we give a short description. And this is what Lint is using. This is the IDE integration. Anytime you have a Lint check yell at you, this is what's happening under the hood. It's being reported at a specific context in your abstract syntax tree. That was the detector. It's the most complex piece. It's scouring through your code, sometimes recursively, and it finds the problem that we're trying to solve. Now we'll talk about the simplest piece, which is the registry. This is just a listing of all the issues that we've created. Now, there's a default registry that's built into the Lint API and part of the Android open source project that lists out some 200 or so issues. But we can't hook into that. Since we're creating our own custom lint checks, we have to provide our own custom special registry. So as such, I just call it custom issue registry. And I extend from the Lint API's issue registry class. And this is how the Lint API will know what issues we've defined that are new and what issues it should now start reporting with our special detectors. And what we'll do here is a few method overrides. First being get issues, which will just be a list of issues. For us, it's kind of arbitrary. It's just a single one, so not too exciting. But you could imagine having a long list of domain-specific issues you've created for your company. Now, the next piece, in our Gradle file, we have to define what our jar will be looking like. The idea here is that we need to provide some sort of package name for our jar. Here, use com.getluma.lint, because that's where I keep all of my lint checks for my company. Give it a version name, because obviously it might change over time. And most importantly, we have this manifest block. And here, we define our attributes for what our lint registry is. So this will be information packaged with your jar, so that lint can look at your jar and know how to use it. Without this, you just kind of have a useless jar file. It might have all your lint checks and your detectors and all that. But lint as a utility will have no idea what to do with it. So this is important. With this lint registry attribute, we're pointing to our custom issue registry that we've defined, so the lint utility will find it and then have that listing of issues that we've created. So this is an important step of hooking into the lint utility. So we've seen how to update our dependencies, creating an issue, detector, the implementation, and the registry. All those pieces together are how you create a lint check. So we would finish with that portion, but like I mentioned earlier, I think testing is an important part of this process because one, it's really useful to have verification that your lint check works as you believe it does, and two, it's really easy. So we're going to have to add some more dependencies. We're going to have to add some test resources, which will be our positive and negative test case files that we'll be looking at. And then we'll test the registry as kind of a sanity check of making sure it's what we expect. And then we'll test the detector, which is kind of the interesting part of making sure our lint check behaves the way that we want it to. The last thing we would want is a static analysis tool that tells us wrong information or flags incorrectly. So I'm using JUnit 4.11. Obviously, you could update to 4.12 or use a different version if you want. And the Lint API provides us with this lint test package, and we have their test utils that we'll also be using to actually run lint explicitly. So a few dependencies, but nothing too crazy. The important part is creating your test cases. In a resources folder inside of your test package is where I usually keep mine, and I create it on a issue by issue basis. So I just name it in my enum package, since it's named after the ID for my lint issue that I've created. And I provide an empty test case, so a case that will always just fail in the sense of the issue won't be found there. And then I provide a positive test case of the enum being there, and so it should trigger my lint check. And obviously you could have many, many more test cases as would be appropriate. But at the simplest level, we got a positive, negative case. The first thing we'll check is our registry, and testing it is pretty straightforward. We just got to define our custom issue registry, we'll instantiate it, and the next step will be to make sure it contains what we expect, which for us is two things. We want to make sure it has the number of issues that we expect so that we're not caught off guard if we only added one issue, but really we found 4. That would be surprising. And we want to make sure that it has all the issues that we actually defined. So basically it's a sanity check of did I create my registry correctly. More interesting is our detector, which we have a nice handy lint detector test provided by the Lint API that we can hook into, which will make it a little bit easier for us. So I call it enum detector test, and we have a few methods to override. First is getDetector, which is the detector to be used for this test case. For us, it's our new enum detector, and you'd pass in whatever you want. The second are the issues we want to test with that detector. For us, it's just going to be our single issue that we defined inside of our enum detector. If you had a more complex use case, your detector, like I mentioned earlier, might have multiple issues associated with it, and you could split them out into their own classes. But here, I only have one issue and only one detector, so I kind of bundled them all together inside of the detector. Now, to actually run our test case, we're going to have this test empty case, so we're testing the simple one that should have no lint warnings associated with it. And I'll define the file name, and then I'll assert equals. And that no warnings is just the default message Lint gives whenever it doesn't find anything wrong with a file. It's not often that I get to see no warnings told to me by Lint, but this is one of the rare occasions. The second parameter is that lint files, taking in the file name. That will actually run lint as a utility on that particular file and then give you the text output. So the idea here is that we're just checking that lint being run on our particular test case file has no warnings. Now for the empty case, this is easy. We know it's going to say no warnings if nothing's found. But the other case is a little bit harder. So here it's really ugly, but we have to construct what that error message might look like, because you don't really have any great way of knowing beforehand. So you kind of just have to run it once, let it fail, and then use that message for your test case. But the general idea is the same. We have our file, and we have to construct our warning message instead of having that default no warning message. And then we still call lint files onto that file name. Here we're constructing it, and again, some of these pieces we've defined elsewhere in our code base, so I know what they are and I'll use them. But other pieces like the braces and the new line and the warning, I kind of just had to run in and figure it out. And sadly, there's not a better way of doing that I know of. So if we want to run these, we just do a good old Gradle wrapper clean build test, and it'll give us some output hopefully and be a build successful. And that will be running in our nice little lint project our test suite that we've created for it. And I highly recommend doing that because it gives you some level of certainty that your lint check, again, does what you think it will. And I created a nice little utility because, remember, in the end, our lint checks are going to be packaged into a jar file. So I wanted an easy way to move that jar file from my build outputs to my home directory, so where I'm keeping all of my custom lint checks. So I just call it install, and it'll copy from our output into my home directory's Android lint. And using that would just be a nice good old Gradle wrapper, clean build, and I throw in a test there for good measure, and then install to copy over that jar output. And of course, you could use that jar locally like we do here, or you could throw it into continuous integration so your whole team can use it. Now, if we want to look at a particular lint issue and figure out what it's about, what it's doing, and this is kind of great for exploring lint and seeing what the different issues available are, you can just do a nice lint -- show on the enum, and it'll tell you all about it. It'll give you the ID, a summary of it, the explanation, priority, everything that we defined earlier on our issue. And I don't actually believe the advice I say there. So enums matter. Finally, if you actually just want to run lint as a whole, you can just do a good old Gradle wrapper lint, and it'll output in your build output lint results.html, which is a horribly styled HTML page that looks something like this. It'll just say lint report and then list everything that you care about. Mine will say, hey, there's a nice little warning sign, and then enum, avoid using them. So that's how you just run it standalone. And of course, you could also right-click and in Android Studio and do like an analyze code if you just want to use your IDE integrations. And in the end, once you've bundled your new jar inside your home directory, and now that you have it in your local system, it'll start running for all of your projects. So in my sample code, I actually created this lint check, and now it always shows up in all of my projects. But as we learned, I can suppress it at will. All my source code is up here on github.com bignerdranch, Linette, Linette being the French word for the word lint. Are there any questions? Can you ignore per package? Yes. That would be using the lint.xml at your top level file. I believe you can specify which files that it should care about. I didn't really show a very complex example there, but look at the documentation. It does a good job of how to suppress and ignore lint checks, but not so good a job on how to create them. Well, thank you very much. Matt Compton. You can reach me at compton@getluma.com or Twitter @ambergleam. So thank you very much.